Hello friends, welcome back to our channel. So in the previous session we have discussed about the anomaly and types of anomalies, and coming to the conclusion, in order to avoid the faults in the database, that means anomalies, the only one solution is to achieve the normalization, right? So that means splitting the tables. So before going to the normalization, first let us discuss about one topic called a functional dependency. Functional dependency. So if you are aware about this functional dependency, it would be very easy to understand this normalization process, that means the splitting of tables. So first let us discuss about this functional dependency. In this session I will give you what exactly this functional dependency mean, and in our next sessions we will see different types of functional dependencies and some axiom properties, right? Then we'll start the normalization process. So coming to the first one, functional dependency. So this is nothing but a relation among one attribute with another attribute in a table. So it's a relationship. It's a relationship between one attribute with another in a table. So the relationship between different attributes. We know that a table contains of different attributes, so the relationship, and it is usually denoted as arrow mark. Okay, so if x and y are the attributes, then the functional dependency is x tends to y. So if x and y are the attributes of a relation R, that means a table, okay, then the functional dependency is represented as x tends to y, x arrow mark y. So here the arrow mark represents this functional dependency. So here that implies so x determines y, or we can also say y is functionally dependent on x. So this is the conclusion. That means if you represent x tends to y, that implies x determines y, or y is functionally dependent on x, right? So here it's a table. Let us take this table. So one attribute is x, another attribute is y. Okay, so here this implies if we know the value of x, we can identify the values of y uniquely. Okay, if you know the value of x, we can determine the value of y, right? So for example, let us take some values. Okay, some values. So after that I will give you an example, right? So let us take some values. If you know the value of x, we can get the value of y. So for example, if x is equal to 20, that implies from the table y is equal to 6. Okay, so such type of dependency we call it as a x tends to y, and here x is known as determinant, and y is called as dependent because y value is dependent. And here one question is whether x is a single attribute and y is a single attribute. No, x can be a set of attributes and y can be a set of attributes. So that means a set of attributes can determine some set of attributes of y. So here, so x and y can be single attribute, or set of attributes, right? And one thing, when we call it as a functional dependency, so here See, x tends to y is functionally dependent if it satisfies a constraint. So it should satisfy a constraint. So what is that constraint? So consider any random tuples, two tuples. So let us take a random two tuples. So if t1.x is equal to t2.x. So if you consider two tuples, so if both the tuple values, x values are equal, okay, for example, if you consider here, consider these two tuples. So this is a tuple 1 and tuple 2. Randomly you can select two tuples. So if both the x values of both the tuples are equal, then t1.y must be equal to t2 of y. So the corresponding y values also should be equal. So here you can observe t1 of x is 10, t1 of y is 5, and t2 of x is 10, still t2 of y is 5. So we can say it as a functionally dependent. For example, if you are not having this value and if you are having some another value, now what happens? t1 of x is 10, t2 of x is 10, both are equal. So we have to compare the corresponding y values. So here y values we are having two possibilities. If x is equal to 10, then y is equal to either 5 or 8. Right? So in this case we can't consider this x tends to y as a functionally dependent. So in this case x and y are not functionally dependent, because by getting a value, by using the value of x, by knowing the value of x, we can't determine the value of y, because here y value is two values. Y is having two values for the same x value, right? So this is a very important constraint. So if you want to finalize the functional dependency, we have to find out this one. So x tends to y. So here x and y are maybe the single attributes or the multiple attributes. So x tends to y is functionally dependent if it should satisfy the constraints that randomly select the two tuples t1 and t2. So the t1.x and t2.x both are equal, then corresponding y value should also be equal. For example, here I am not having this one, so I am having this one 15. So now the x and y are functionally dependent, because if you are knowing value of x, we can get a y. So if you know x is 10, 5, 26, 37, 50, 15, 18. So here t1.x is equal to t2.x. This doesn't happen here. So here both x values are not same. Okay, so we are not having the more than one, the same x values, duplications. So that's why we can say this as a functionally dependent. X tends to y is a functionally dependent here, right? So hope you understood. X tends to y is a functionally dependent when x determines y uniquely. X determines y uniquely. That means if it satisfies the constraint t, if both the x values are equal for different tuples, it should contain, or it should determines the same y value also. The corresponding y values also should be same. If both are different, automatically it will be not a functionally dependent, right? So then here we can say a functionally dependent, fully functionally dependent, or a partial functionally dependent. Fully functionally dependent or partial functional dependent. See, full functional dependent and partial functional dependent. So when we call the functional dependency as a fully functionally dependency and a partial functional dependency. So as we discussed now, x and y can be set of attributes. So x tends to y is said to be fully functionally dependent, is a full functionally dependent if we remove any attribute of x. any attribute of X violates the functional dependency rule. Violates the functional dependency rule. That means we said that X and Y are the set of attributes. So for example, A comma B determines C, right? A comma B determines C. That means the combination of A and B will determine the C. So C is a functionally dependent on both A and B, right? So here if you remove B, so then if A and C is a functionally dependent, okay, is functionally dependent, sorry, if it is not a functionally dependent, okay, if it's not functionally dependent, or B tends to C, that means if you remove A, it's not a functionally dependent, then we call it as a full functional dependency. So even though if you are removing one attribute from X and still it doesn't obey the functional dependency rule, that implies this X tends to Y will be the full functional dependency. So that means we can determine C only by the combination of A and B. So if you remove any one of the attribute, either B or A, it doesn't obey the functional dependency rule. So this is called a fully functional dependency. And coming to the partial functional dependency, the quite opposite. So X tends to Y is partial functional dependent if we remove any attribute of X doesn't violates FD rule, then we can say it as a partially dependent. For example, so let us consider A comma B tends to C. So in order to get the C, we have to know the values of A and B, right? And if A tends to C is still functionally dependent, that means if you remove B, the remaining functional dependency A tends to C is also a functionally dependent. That implies this is a partial functional dependent. Okay, so if A tends to C, F and D, or B tends to C also a functionally dependency, then we can say it as a partial functional dependency. That means removing a part of, that means an attribute of X, still the function, it obeys the functional dependency, then we call it as a partial functional dependent, right? So hope you understood the functional dependency, the full functional dependency, and the partial functional dependencies, right? So let's move on with one small example, and I will show you the functional dependency, what is a full functional dependency and what is a partial functional dependency. So let us take this example. So student details. Now we'll see what is a functional dependency. So what is a functional dependency, and what are the partial functional dependencies and full functional dependency. Now, as per our discussions, we have to check the functional dependency with the following constraint, right? So let us check here the functionally dependencies. So first one, SID tends to SNAME. So let us check whether it is a functionally dependent or not. So how we have to check? We have to consider two tuples, okay, such that the two tuples X value should be equal to the corresponding Y values. For example, you can consider these two tuples. So T1 of X is equal to 101 and T2 of X is equal to 101. So corresponding T1 of Y is equal to Sundeep and T2 dot Y is equal to Sundeep. So it satisfies this one. Okay, so here it satisfies the one, right? So that means it satisfies the constraint. Once again, go with any other any other constraint, see any other tuples. So there are no more repetitions in SID. So we can consider SID tends to SNAME as a functionally dependent. So SNAME, it depends on SID. So if you give SID, we'll get the SNAME uniquely. There will be no duplications here. Then, so along with the SID, we can also give the address We get a unique address. Okay. What about SID with a course? So this will get, because 101 Bapatla, 101 Bapatla. So there are no repetitions here, leave it. SID tends to course. So course 101 Python, 101 Java. So here t1.x is equal to 101, t2.x equal to 101, t1.y is Python and t2.y is Java. So it differs. So we are not having the same value of y with the x. So this we cannot consider as a functionally dependent. Course doesn't functionally depends on the SID. Similarly, you can go with any other. So course and S name. Consider course and S name. Python. So different y values. Okay, different y values. So here it is x and here it is y. So different y values. So this also we can't consider it. Okay. Similarly, SID tends to any other. S name tends to SID. So if you know the name, shall we get the SID? So Sundeep. So if you take these two, we are getting the corresponding y values, same y values. And here we are having a 2 Saradhi, but there are different x values. Y values. So we should not consider this one. So these two are the functionally dependents. So as we said that x and y are not a single attributes, it can be a set of attributes. So now we can check with that SID comma S name gives the course. SID comma S name gives the course. Let us check here. So we have to check both. We need to check both SID and name. 101 Sundeep Python, 101 Sundeep Java. So both. No, it's not a functional dependence. Next, SID comma course combinedly can get the S name. Combinedly can get the S name. So 101 Python gives the name Sundeep and 101 Java, both are different. So we should not divide this one, right? We have to find out with a combination. So here the attributes, if you know both the SID and course, we can get the S name. So here 101 Java, so that is a unique. 102 Python, it's a unique. 102 and C, it's a unique. 104 Java, it's a unique. 105 and Python, it's a unique. So this is a functionally dependent. This is a functionally dependent. So like this, we have to find out all the possibilities and we have to check for the functional dependencies with whether it is following the constraint or not. Now coming to the full functional dependent and the partial functional dependent. Coming to the SID course, consider this functional dependence because it is a set of this one. So course tends to S name, and you can observe if you remove this course whether it is still in a functionally dependent. If it is still a functionally dependent, yes. So if you remove the course, still it is in a functionally dependent. So that's why this we call it as a partial functional dependency. Partial functional dependency, right? So if you remove any one attribute from the X, still the functional, still it obeys the functional dependency. We call it as a partial functional dependency. So we are removing course here, still it is in a functional dependent. SID tends to S name, still it is a functionally dependent. Now coming to the full functional dependence. So let us check on this one. S name dot a course gives a SID. Let us check this one. S name and course. Sundeep and Python gives 101. Sundeep and Java gives 101. And Saradhi and Python gives 102. Saradhi and C gives 103. So there is no repetition. So this is a functional dependency. Yes, obviously it will be a functional dependent. But we have to check whether it is a partial functionally dependent or full functional dependent. For example, remove this course. So if the dependency S name tends to SID, if SID is functionally dependent on S name, you can observe now. So this is a X value and this is a Y value. So T1 of X, T2 of X, T1 of Y, T2 of Y. So what is the T1 of X here? Name. So if you consider these two tuples, okay, so we'll get a Sundeep, T1 of X, and here also we'll get Sundeep. So here we'll get 101 and 101. Yes, yes, right? Randomly select one more table. So let us take these two things. Now let us consider these two things, 102, 103. So the name T1.x is Saradhi. So if you consider these two tables, 102 and 103, T1.x is equal to Saradhi, which is equal to T2.x also, right? But T1.y is equal to 102, T2.y is equal to 103. So the name Saradhi can get two different SIDs. So this is not a functionally dependent, right? So this is not a functionally dependent. Now consider another thing. So here, after removing this course, S name tends to SID, which is not functionally dependent. Now remove this course, I mean S name. So let us check with the course name. Course with SID. So if you know the course, shall we get the SID or not? So let us consider the things. Course, take this one. Okay, so course T1.x is equal to Python and T2.x equal to Python. So we have to consider only these things. If the two tuples, the x value of two tuples are equal, then only the corresponding y value should be equal. So here I am taking two, Python, the corresponding SID is 101 and 102. So it may get 101 or 102, which is T1.x, sorry, T1.y, which is T2.y. So again, it is not a functionally dependent. So this complete dependency is a full functional dependency. So if we remove one attribute from X, it violates the functionally dependency. It doesn't become a functionally dependent, right? So that's why we can say this one. This one as a full functional dependency. So we have to find out the functional dependencies and then we can find out the full functional dependency or partial functional dependencies, right? So if you know the concept of these functional dependencies, as I said earlier, it would be very easy for you to understand the normalization process. That means dividing the tables, right? So hope you understood this functional dependency, and if you are having any doubts, you can post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.